So based on the Desmos activity today, we're going to use those concepts and apply them to a variety of situations. Use the givens in the diagram and what you know to be true to solve the problems below. So in number 1, we have a triangle with 3 side lengths given to us. The question is, which angle is the smallest and how do we know? So as we learned in our Desmos activity, the size of the angle determines the size of the side of the triangle, or the length of the side of the triangle. The larger the angle, the larger the side length. The smaller the angle, the smallest the side length. If we're talking about the smallest angle, we should find the smallest side length and go from there. So our smallest side length of the 3 that were given is here at 6.87. The angle opposite it is here at angle B. So again, when we're talking about naming angles, we have to use the angle symbol. We also use capital letters. Again, since this angle is a standalone, we could say angle B. We could also name it angle ABC or angle CBA. All of those would be acceptable results. And again, how do we know it's the smallest? Because it's across from the smallest side length, your segment AC. Now for number 2, we have a triangle given to us with 2 angle measurements, both being 57 degrees. Our question is, which sides are equal to each other, and how do we know? So again, angle measurements determine the side lengths and vice versa. So if I have angle measurements that are the same, that means their side lengths would also have to be the same. So those sides across from each of those angles would have to be congruent to each other. What sides are those? Those are your segments AB and segment CB. Again, 2 capital letters talking about the sides that have the same measurement. Again, they're across from the congruent angles. So again, with those concepts in mind and the ones we did in Desmos, we have 3 diagrams here, and there's something wrong with each of the diagrams. Our job is to figure out what is exactly wrong with those diagrams below. If you look at your first one for number 3, what should be standing out to you is that we have 3 equal sides. Well, if the sides are equal, that means the angles opposite them should also be equal. Every single one of them would have to be the same measurement. And if we look, that is not occurring here. That is what's wrong with the diagram. Remember, when we talked about triangles having 3 equal sides, those are equilateral triangles. If all 3 of those angles have to be the same, 180 the total for the angles in a triangle, divided by 3, the measurement should all be 60 degrees. For number 4, if we look at the diagram, things that are standing out, we have 2 side lengths of 4.99. Well, if the sides are congruent, that means the angles opposite them should also be congruent. Well, if I look, that is not occurring here. I've got 2 different angle measurements. So that's violating our rule. Again, if 2 sides are congruent, the angles opposite them are also congruent. All right, so for number 5, if we look at our diagram for our triangle ABC, what's standing out? Well, you might be looking at the side lengths, and we see we have 2 side lengths of 5 units. Well, if the sides are congruent, the angles opposite them should be congruent. One is 90 degrees, the other is 53, so that's not true. Another thing, if you notice, we have this right angle here. That's the largest angle of our triangle, which means the side across from it should also be the largest side of our triangle. And again, that's not the case because we have 2 sides that are congruent. So either of those 2 explanations would suffice. So now that we have the big ideas under our belt, let's see if we can use them to write and solve equations. So here if we look at number 6, we want to solve for x. And in our diagram, things that should be standing out to us are these tick marks here for PR and PQ. They're telling us that these sides are congruent. Well, remember, if the sides are congruent, the angles opposite them should also be congruent. So that means angle R should be congruent to angle Q. Angle Q is defined as 2x, so that means angle R should also be defined as 2x. So if we notice now, each of the angles are labeled in our triangle. So we know the sum of the interior angles is 180 degrees. That means 2x plus 2x plus 40 equals 180, or two sets of 2x plus 40 is equal to 180. So either of those two equations will get you going. At this point, we just have to solve for x. So we can combine some like terms here on the left-hand side or distribute. And we've got 4x plus 40 equals 180. We would subtract 40 from each side, meaning 4x is equal to 140. We have to undo this multiplication here by division, which gives us an answer of x equals 35. You can always check to see if your solving is correct by taking the value for x and putting it into the expression. 2 times 35, that's 70. This is also 70. They're supposed to be congruent, they are. 70 plus 70 is 140, plus 40 is 180. So you've verified that you have the correct value for x in your situation. If we take a look at our problem number 7, we see in our diagram these tick marks for angle S and angle T. Why are those important? They're telling us that those measurements are equal to each other. Well, if the angles are equal, that means the sides opposite them or across from them would also have to be equal to each other. That helps us write an equation. If SV is equal to TV, that means 2x plus 6 is equal to 3x minus 6. We can now undo this equation to solve for x. How would we do that? Well, we would subtract 2x from each side, add 6 to each side, therefore x is 12. Let's take a look at number 9. Again, we're trying to solve for the value of x. What's standing out to us in this diagram? Well, we have a series of tick marks. We see that DK is congruent to TK. Well, if those sides are congruent, then the angles opposite them should also be congruent. Angle D and angle T would be the same measurement, being represented by 6x plus 6. We also see these double tick marks telling you that KP is congruent to KQ, which means angle Q is also congruent to angle P. That's not helping us as much here because we don't have any information about either of those angles. The last piece that we see is PKQ. This angle here is 2x. Well, what's nice here is we have a pair of vertical angles being formed by these intersecting segments. So if PKQ, that angle is 2x, angle TKD is also 2x by vertical angles. So we could start writing an equation because now we know all the angles for our triangle KDT. 6x plus 6 plus another 6x plus 6 plus 2x is equal to 180. You could also write it as two sets of 6x plus 6 plus 2x is equal to 180 and get the same result. Regardless, we have some simplifying to do on the left-hand side of our equation, putting some x's together to get 14x plus 12 equals 180. Then we can undo the addition of 12 by subtracting 12 from each side. Then undo the multiplication of 14 by dividing by 14 on each side, and giving us a value of x equals 12. Now let's take a look at your problem 13. We want to solve for x. Here we have our triangle ABC, and we have one angle for B labeled as the quantity x minus 5 squared minus 21. We're also given this information here that triangle ABC is equilateral. Well, what do you know about equilateral triangles? Equa means equal, lateral, sides. Equal sides. We have 3 equal sides to our triangle. So AB is congruent to AC, which is also congruent to BC. Well, if we have equal side lengths, the angles opposite them also have to be equal. That means angle C would be congruent to angle B. And that also means it's congruent to angle A because all 3 sides have the same measurement. This is giving us all 3 angles have to be the same measurement. Well, we know the sum of the angles in a triangle is 180 degrees. If I divide that into 3 equal pieces, That means each angle has to be 60 degrees. Now, if we look at this diagram even more, we should be able to see an equation being developed. We know the most about this angle B. X, the quantity x minus 5 squared minus 21 is equal to 60 degrees. We can use that equation to help us solve for x. So how could we undo this equation to solve for x? We could add 21 to each side. And now we've got our quantity, x minus 5 squared is equal to 81. Anytime you have a quantity squared, to undo that, you take the square root of each side. That would leave us with the absolute value of x minus 5 equaling a distance of 9. Again, since we're talking about traveling a distance, we can go to the left and right of 0 on our number line, a distance of 9. So to show that you're going to the left, remember we do -1 times what's inside the absolute value bars equals your distance, and 1 times what was inside the absolute value bars equals your distance. These are the two equations that we're going to have to solve to find x. Well, anytime we're talking about multiplying, we would divide to undo it. So on the left side, I'm going to divide by -1. On the right side, I'm going to divide by a +1. Where would that leave us? Well, the equation on the left side would be x minus 5 equals a -9, and on the right, x minus 5 equals a +9. Here, we just have to undo the subtraction of 5 by adding 5 to each side of these two equations. So, the equation on the left would give us x equals a -4. The equation on the right would give us x equals 14. So these are the two values of x that satisfy our equation.